Hello everyone, welcome to Learn Overflow. In this video, we will discuss about uh, another LeetCode problem, that is the binary tree right side view. This is a medium level problem, and we will understand what this question is telling us all about and how we can think of finding a solution in this kind of question. Also, we'll see if there's any other similar question that comes similar to this questions also. So before moving on, make sure to subscribe to this channel for regular LeetCode videos, and also like the video if you haven't already. So let's understand what the question is all about. First, it says given the root of a binary tree. So we are given a root of the binary tree, and imagine yourself standing on the right side. So you are a person over here, standing over here. Okay, so you are standing on the right side of the binary tree, and return the values of the node you can see ordered from top to bottom. So you are standing on the right and you need to return the value of the node that you can see from top to bottom. Okay, so that's all you need to do. That's the right view. So whatever with the rightmost value at each level we have, so we need to return that value. Okay, so just as an example, see here there is like this binary tree is there, 1 2 5, like 3 and 4. This binary tree is there, and as a result it will return 1 3 and 4. Okay, so the question is pretty easy, but just go ahead to bring whatever is in the right, bring root dot right, whatever is there, you just keep on adding them to your answer list and return that. So that can be one thing that you can think in the initial case, right? But the question cannot be that easy when it's a medium level question. Let's see what can be like the difficulties in this question. Okay, so let's see, say there is a binary tree for us, like the root, it's left. Okay, it's right, uh, then again it's left, uh, it's right, fine, then say again you got it's right, the right of right, you got it, and then you found something like this. Fine, so I'm just trying to build one binary tree. See, if our binary tree is something like this, now see what will be our like right order, like right view. For the right view, you will find this node. Fine. First, you will find this node. Then you will find this node. Right. Then you will find this node. Fine. Then what? Then is it the end of your answer? No, why is it not? Because you are standing on the right over here. This is where you're standing, right? So you need to see all the nodes from right. So what are the nodes you can see from the right? After this node, you can see this node, right? Then you can see this particular node. After that, you can see over here, and then you can see over here, right? So this is what you are going to see. It's not that you are seeing only the nodes on the right. So it shouldn't be like you keep on traversing whatever the nodes on the rightmost and you just return those. No, this is not the thing you are getting over here. It's simply, it can happen that the number of nodes, like other nodes, can maybe on the left subtree as well. Okay, so you need to keep a check, like how to do that. The main idea behind doing this, it's like a pretty simple DFS or BFS solution. You can go ahead with either approach, but what we need to do, we need to keep a check, like whatever be our level, say level 0. Okay, from level 0 we'll take the rightmost value. Okay, for level 1, whatever being the rightmost value we are coming across, we'll take that value. How will we do that? We will traverse our binary tree in a either way. Say I say you are doing it in a DFS approach, and in each step when you are going to its left or you're going to its right, like root dot left or root dot right, you keep a check of the level being you start with 0 and you keep a check of the level at each place. Okay, and see the number of elements in our answer array is also equals to the level. It should be like if it's 0th level is getting added, the number of elements in our answer will be one element will be there. Okay, then if it's one like the first level, some element getting added, then the level like length of the our answer array will be 2. Like that's how it's done. So if we are level 1, it should be level 2. So our elements count should be level 2. If we already know that we got our level count like on a particular value, That means we got our rightmost element on that value. Okay, so the first target of us is not going to left. Rather, our first target of us is like traverse to root dot right. Okay, at each node, traverse to its right first. Okay, and then if we are at a particular level, add that node value to our answer. That's the list we need to return, and keep on traversing to the rightmost all of the values possible, and then go back and then keep traversing to the left. For left, you will find the same level again and again, but those values are that level values are added, and then I say at this node, you first traverse to its right, and then traverse to its right. You added all the values, and then you move back and traverse to its left. If you find that this level value is already being added, then you traverse right, and then you find it's null, so you cannot traverse right, so you traverse left. So this is how you should go ahead with this kind of solution. Okay, like I'm just talking about an approach. You can go ahead. So let's write this code and let's understand it further. How exactly you can visualize this code is more like you first go to the right, all the rightmost element, and keep adding the elements whenever you got a particular level value. Okay, so that's the basic understanding we have over here, and that's how you will go ahead and solve this question. Let's write the question, and then I will again explain you how you can how the code is actually working for us. I will go ahead with the DFS approach, with every step being on the or DFS approach on the right route first. Okay. All right, so here we find that this solution works for us. So let's understand what exactly we did with our solution. We simply took an answer list that the list we're supposed to return. Okay, and based on that, what we did, we further took a supporting function for us to do our DFS operation, and we passed the root, our answer list, and our current depth being the 0. Okay, so and ultimately after returning from the DFS function, we will return our answer. That's the final return to this answer, like whatever the answer of this particular question is. Okay. So in our DFS function, we got our root, we got our answer list, and we got our depth being the what's the depth we attained till now. Okay. So the first thing we did was we just checked that if the root is null. Okay, it's the best case to just note that till what point you should go in depth. Like if root can be done in the first case, say we'll traverse to the right, it can be done at some point, and that's the point we should return back to our all the operations. Okay. And then this is important step that it's building our answer list. What we're doing, we're checking like if a depth equals like answer to size. So how does it work? Like depth initial case is 0. Okay, and initially our answer limits like our answer list has how many elements? Initially our answer list doesn't have any elements. Right, that's the topmost root we have. So in that case, what happens? Depth is 0. Answer also doesn't have any elements, so it's 0. So we're just taking depth and answer size step. We just added a value like a current root dot var to our answer. Okay, while on the right hand side, say we move let's listen further. Let's next step. Then we'll come back to the step again. So the first we just went ahead to root dot right. Okay, we took the rightmost element first. So at each node we are looking forward to the rightmost element. Okay, and then we just took root dot right with our answer being passed to it, and also the depth is increased by 1. Okay, so that's what we're doing. And say we found the right is null, we'll again move back to the left, and we'll have the current depth plus 1. So remember, if element is not there in our array, so if I just take 3 elements, say this is one element, this is say this is one element. Okay, and then moving with that, you have on left, you have on right. If you got an element and you got an element, and then to its left you got an element. Okay, so if our tree is like this, let's understand how this will happen. First we will check over here. Our depth is 0. Fine, we started with 0 over here, and then our what is the answer list? Answer list doesn't contain anything. We got like 0 equals 0. That's the size that we got over here. Okay, so we added our current root to root dot 5. Fine, we got it. Now next thing, we move to its right. We move to its right, and we made the depth to be 1. Like depth plus 1, you can see. So depth, we made the depth plus 1. And now what happens? Well, our depth is 1, and our answer array has only one element till now. That's why we return a size of 1. So again, we find that this is equal, and we added our this particular value. Okay, this particular value for our list. Then we'll find that on its right there is a null. So it return back to this node, and then it will move to its left. It will move to its left. It will find null. So it is return back again. Okay, fine. So it just tells all the nodes, so it will return back again. Fine. And then what happens? It's like after that it will simply go to its left. Fine. Because the current value was depth was 0 at this node, at this particular node depth was 0. So it will go to its left being called to this function. So depth become 1. So depth become 1. We'll find answer array length is 2, because there are 2 elements, and the depth at this position is 1. So there's no point going ahead with more like we got add this value. Then we'll try to move to like on this particular node. We'll try to move to its right being null. We'll move back, and then we'll move to its left. Fine. Once we move to its left, we find the current depth being 2, fine, and our answer array also contains 2 elements. So we'll add this position value, okay, this position value to our answer array, and after adding this position value, we find that both of its child nodes are null. So return back, return. After this node, we return to our main calling function, and thus we find all the values we have over here. Thus we noted down this also, and also on the point of this two nodes. So I hope I can make understand what is the working process of this particular code we have over here. Okay, so this is a DFS approach. If you wanted, you could have used a BFS approach as well. You should have looked forward with using a queue and then keeping a track of all the rightmost node first and then moving towards left. All right, so that will be a basic approach. You can try on that, but this solution is also pretty much faster. You can see so 1 MS solution is pretty fast solution. So that's all about this video, guys. Thank you. I hope I can make you understand how this works. If you have any doubts or anything like that, make sure to comment down below. Also, there's a similar question if you remember. This question is what we call the right view. Fine, like if I just take on this is the right side view. Okay, so you'll find another question like this where it is called the left side view. The same question happens, but you need to return the left view, like all the values visible from the left. Fine. So that will be an idea more or less over here. Okay, so that will be a similar question you can try also. So that's all about this video, guys. So hope to see you soon in my next video as well. Thank you.